Hello, everyone. I'm Barbara Corcoran, Vice President of Education at the New York Botanical Garden, and it is my great pleasure to welcome you all today to what will be a fascinating presentation and conversation with forest ecologist Suzanne Simard. Suzanne's work has influenced filmmakers like James Cameron and Avatar, and her TED Talks have been viewed by millions worldwide. Today, Suzanne will be sharing insights from her important new book, Finding the Mother Tree, which explores the elaborate systems trees have developed to communicate, cooperate, and compete with each other. This investigation of trees and the way we share their world, they share their world with us, is dear to our hearts here at the garden, where we tend to some 30,000 trees found in the garden's 50-acre old-growth forest and in our curated collections and all across our 250 acres. So now with us today, to introduce Suzanne is someone who knows more about all those trees than anyone, the garden's Vice President for Horticulture and Living Collections, Todd Forrest. Todd is responsible for all the gardens and grounds here at NYBG. Previously, he worked at the Arnold Arboretum at Harvard University. He has a master's degree from the Yale School of Forestry and Environmental Studies. He is a true advocate for historic trees, forests, and public gardens. At the garden, he's directed the collection's master's plan and forest management projects. He's overseen several successful restorations of our historic landscape, including the Ross Conifer Arboretum, and he teaches about trees in our School of Professional Horticulture. And in addition to his many articles and interpretive materials, Todd was the principal author of Magnificent Trees of the New York Botanical Garden. But before I hand things over to Todd, I want to encourage you to participate in today's event. If you want to make a comment during the presentation, use the chat button. And if you'd like to ask Suzanne or Todd a question directly, please use the Q&A feature. Also, if you spot an interesting question in the Q&A, you can like it. Liked questions flip to the top of the list and will be asked first. Again, I'm so glad to have all of you with us today. And now to introduce our featured speaker, here is Todd Forrest.
Thank you, Barbara, and welcome everyone to what is sure to be an enlightening and I hope inspiring conversation. It is my honor and pleasure to introduce today's speaker, Dr. Suzanne Simard. I am afraid that I am at a bit of a loss today. My assigned medium of a brief introduction is, frankly, insufficient to characterize Dr. Simard's remarkable gestalt. Do I focus on her groundbreaking scientific work? Dr. Simard is a forest ecologist at the University of British Columbia with more than 200 scientific papers to her credit. She has been the leading figure in research into how the rich panoply of species within forests interact through complex communication networks and feedback loops. Her work has greatly increased our understanding of how forests work and inspired a whole generation of forest ecologists. Or should I focus on her courageous science-based advocacy that began while she was working within the tradition-bound and profit-motivated Old Boys network of industrial forestry? Dr. Simard, who grew up in a family of foresters, started her professional career scrambling along skid trails alongside timber cruisers, choker setters, fallers, buckers, chasers, and sorters. She knows the business end of a peavey from that of a pike, which may explain where she found the courage to take on environmentally disastrous policies of the forest industry. Or should I focus on her remarkable capacity to engage and inspire broad audiences through her TED Talks, documentaries, interviews, and her frank and moving memoir, Finding the Mother Tree? I guess my only comment there is that Dr. Simard has achieved something that most scientists can only dream about, an oeuvre that is as accessible as it is impactful. Today, Suzanne will give a talk, which we will follow with a conversation. I have some questions prepared, and if time allows, as Barbara said, we'll introduce questions from the audience. Please ask your questions via the Q&A function, and like questions again, move to the top. So I hope you are excited as I am to hear what Dr. Simard has to say this afternoon, and please join me in welcoming her to the conversation.
Thank you, Todd, for that lovely introduction. And thank you, Barbara, as well. It's my great pleasure to be here. I'm actually a long way from you right now. I'm in British Columbia. I am in a little town called Nelson, which is just west of the Rockies. It's in the unceded territory of the Ktunaxa, the Sinaiaks, and the Okanagan First Nations. I'm going to talk to you today about, my own development as a scientist and communicator. So, I, like everybody, I grew through my life, and I followed this path of development. And, in a lot of cultures, this is signified by the spiral, which I'm showing you here, where, you start as a young person, born not really that aware, but accept of yourself, your family, your mother, your father, and you grow out and spiral out. And you can imagine yourself like an eagle spiraling up and up, up and up, understanding your role in your community, as well as the value of community, the value of companionship and relationships. And then as you grow and grow, your knowledge of your environment and the world grows as well. And this is embodied in so many cultures. You can think of the medicine wheel in our Native American cultures, where the integration of the mind, heart, body, and spirit comes as you grow and develop as a person. And of course, we spiral down as well at different points in our lives, and spiral back out as we learn and understand. And I think in my book, I try to explore this development in myself and my awareness. And it's still, of course, incomplete and always growing, and so exciting to learn. Let me just explain a little bit more of where my work was done. And I'm just showing you an old map of North America. When North America was first colonized, we came, and I am an immigrant from my family came from Europe, from France, and moved across Quebec in southern Canada. But this whole country, this whole continent was occupied or inhabited by people for thousands of years, highly evolved and sophisticated cultures that had their own languages, their customs, their own way of seeing the world, their own epistemologies, their own ontologies. And as colonization and settlement occurred, as we moved west across North America from here in New York, where we were, where I was doing a little bit of reading and realizing that the New York Botanical Garden was the territory of the Siwanoy people, and to the south in Manhattan was the Lenape, and to the north the Mohicans. And of course, there was a great, most of those people don't live there anymore, or they're integrated into society. And I think that, as we move west, we see more and more, especially, where I live of course, I can't say for the North America, but where I live, a lot of the nations are still intact, but have, suffered through colonization in many ways. I'm going to get a little bit into that. This is a closer map of British Columbia. I'm just down here in the Ktunaxa territory over here. This is where I am right now. But in British Columbia, it's a highly mountainous area, right nestled against the Pacific Ocean. And the ocean and the mountains really have contributed to this incredibly diverse environment, where old growth trees live along the West Coast. And also, right down to where I am, I live in what we call the inland rainforest. And there's a great variety of forests. To the north, the boreal forest. All of these are temperate forests, and here there are, dozens of different forest types here, reflected of the climate in the mountains. And so it's reflected in the variety, in the variation in the language groups. There are about 30 language groups, original language groups in British Columbia, and these, with colonization, the nations were split into 203 different nations, which has created all kinds of issues. But it's very complex, and I think I wanted to emphasize this because this long history of living on the land. The Haida Nation, for example, was in Haida Gwaii for, we think, 14,000 years. In these other nations, about 10,000 years. So that's a long time to get to know the land and get to know the forests. And it really was about, living as one with the land. These are the forests I grew up in the inland rainforest. They're cedar, hemlock dominated forests. These are the iconic old growth forests that we often think of on the West Coast. They're so productive. These are carbon hotspots. They store some of the best or the deepest carbon store or stocks are in these forests. They also are home to huge biodiversity as well. I grew up in these forests and my family were horse loggers. These are also salmon forests. So, you know, that diverse landscape means that there are lots of rivers. Those rivers are spawning habitats for salmon, which of course live most of their life in the ocean and then spawn in the rivers upland, and the salmon return to their natal streams and basically are integrated with the land. They basically fertilize our forests as well. And the nations that lived here were very much salmon people and very much cedar people, people of the forests. And they developed amazing, highly sophisticated fishing technologies. This is a weir on a slow-moving river, the Shuswap River, near where I grew up. And this weir was for catching fish, but it was also for counting fish. So they could always be aware of the fish stocks and then adjust their harvest accordingly. It also allowed them to select for the fish that they would let go. So they would always return the mothers, the big mothers, so that they could spawn upstream to produce bigger and healthier populations. And in this way, by being so attuned to the variability and to also always encouraging the population to grow, these populations were kept strong and healthy, and that, of course, was important to the vitality of the people. This is another fishing technology. This is on the Fraser River, which is a much faster flowing river. And of course, it's a completely different way of fishing. And they use spears and dip nets to haul fish out of the river. And here's yet another one. This is on the west coast of British Columbia. These are ancient tidal stone traps where the Heiltsuk, the Tlingit, the Haida, the Kwakwaka'wakw nations built these incredible ancient traps. They're basically just stone walls that are contoured along the estuaries and where the rivers came in, where the salmon spawned. And the idea here is that when the tide came in, the fish would get trapped behind these stone walls. And especially on the ebb tide, they only harvested fish on the ebb tide, and they would passively take the fish or harvest the fish from behind the walls. And they always threw back, just like in the interior forest, always threw back the big mothers in order to encourage and to promote the populations. And so the populations were always very strong and thrifty and diverse. And this was celebrated, you know, this oneness with the earth was celebrated in the art and clothing and longhouses. And this is a longhouse in the Tsimshian Nation. And you can see the salmon being celebrated as an integral part of the culture with the Tsimshian and their livelihoods. And of course, you know, I didn't know this when I started my work, but I learned it later that they also knew that there was in the Coast Salish cultures along from, you know, in Washington all the way up to the North Coast, knew about these fungi in the soil, that the fungal net, they understood that there were these massive fungal networks under the soil that nourished the trees. And they honored these fungi as well as the trees. In fact, they viewed them as their people. You know, there were the tree people, the mushroom people, the strawberry people, as Robin Wall Kimmerer talks about in her book, Braiding Sweetgrass. You know, we are all in this together. And in fact, you know, in all of these cultures, there are words for this, we are one. In the Hamalkaman group of languages, they call it Netsamats, we are one. And I noticed that Kwakwaka'wakw, they have their own word as well as the Tsimshian. And I think worldwide, the Aboriginal cultures all, you know, over thousands of years of living on the land, developing their cultures, saw themselves as one with nature, that we're all in this together, we're all equal, and we all create this biosphere of balance. That's where our livelihoods come from that. But when colonization happened, and so I'm going to turn to a little bit of a darker picture here, all of that knowledge was ignored. When colonization happened in Canada, the European colonists basically moved across North America or Canada, including my own family who came from France and were loggers in Quebec and eventually settled in British Columbia. As we moved across, it was a policy in Canada to actually take the children from the families and put them in these residential school systems. And I think you will have heard in the news that even in where I I grew up in my hometown, they've just uncovered 215 bodies of little kids that were buried around this residential school, because these residential schools were absolutely devastating. And the idea behind that was to take the Indian out of the child. And all of that knowledge that I just talked to you about was completely ignored, and the resources were taken over by the colonists. Now we're going through a truth and reconciliation process to try to reinstate this knowledge, or to reinstate rights and territories to the First Nations, but it's a long, painful process. And I am part of that painful process as well. In forests, what is happening is there is parallels, right? The way we've treated the Indigenous people is also how we have been treated our forests. And the harvesting of our forests, the clear cutting, you've probably heard this as well, that, you know, in British Columbia, we're fighting for our last 3% of these iconic old growth forests, because they've been clear cut and converted to plantations that are basically cleansed of native plants, native trees. And this is in order to promote the growth of what we think of the valuable products, the Douglas firs and spruce that corporations have made so much money from, and trying to replace them with faster growing plantations. And I became a scientist in the milieu of all of this, when clear cutting was really taking off, when planting was the way to go. It was no longer selective logging like my great-grandfather, my grandfather, my father did, who were all settlers, but also just horse loggers. I came into the scene as a forester in the midst of huge clear cutting, and it has not stopped. In conversion of our forests to this without the native plants. They're basically removed, as I said. And so this got me on a line of research about, what are we doing with these forests? We're disconnecting, you know, these incredibly sophisticated systems. And I'd learned actually through my studies at Oregon State University about this work being done in the United Kingdom by a scientist named Sir David Reed, who knew about mushrooms and fungi and these kind of fungi called mycorrhizas, which are beneficial fungi, the fungi that the First Nations people knew about, and discovered through his Western scientific techniques in the laboratory that trees could actually be connected together and share carbon from one to another. I wanted to know whether or not we were disrupting well, first of all, did these networks occur in forests, and what were we disrupting them, and what was the consequence for our forests? And this is just a close-up view of what these networks actually look like. These are root tips of seedlings, and these are the fungal mycelium that can connect seedlings of different, or trees of different individual trees, even trees of different species. And through these linkages, we knew from David Reed's work that carbon can move from one tree to another as though it's moving through a telephone line. And so, you know, I pursued this. I wanted to know, is this happening in forests? And if so, what are we doing? Are we disrupting these networks? And so I went into forests around my home, which, as I mentioned, was around the town of Kamloops, which is where this recent news is coming from. But these forests around Kamloops are dry forests, and they're multi-age forests. They're old forests, so these trees are about 300 years old, the big ones, and underneath them are growing saplings and seedlings that just grow up under the crown of the old ancient trees. And so that means, you know, over time that they have this multi-storied canopy with trees of all different ages. And so we sought to try to figure out, what did this network look like under this kind of forest? And so I got a graduate student named Kevin Byler. He worked for 5 years on his PhD looking at these networks below ground. And we looked at one fungal species only, of which Douglas fir associates with thousands of these mycorrhizal fungi. We looked at one alone. In this forest, there were about 100 species. But we took this one species and we made a map of the forest below ground. And this is what it looked like. This is a 100 feet by 100 feet piece of forest. And these round circles represent trees. And the bigger and darker the circle, the bigger and older the tree. And in the smaller, lighter circles are the seedlings growing up in the understory. And we mapped using DNA techniques where every tree was and where every fungal linkage between trees was of these rhizopogon fungi. And what we found was amazing. And this has launched a whole line of inquiry along the way. So here, a few things I can tell you is that in this map, every tree is linked to every other tree. It might be through a series of hop, skips, and jumps from tree to tree to tree, but essentially every tree is linked to every other tree. And through the forest over the broader network, as we move out from this 100 by 100-foot spot, the entire forest region is actually connected together. I mean, we can disrupt it with rivers and creeks and roads, but essentially the forest is completely interconnected. And keep in mind, this is one map of one species, and there are 100 species in this forest. So the map would actually look a lot fuller if we had everything in there. Another thing to note is the biggest, oldest trees are the most highly connected trees. So, this tree alone, of the 55 trees in this forest, this tree is connected to 49 of the other trees. And so these trees, are special. These big old trees are special. This is actually what you would call this map a biological neural network. In a neural network analysis, when you do graph analysis of these kinds of networks, they call these central points hubs. We have neural networks in our brains, and we have hubs as well that are center points for our thoughts. These other satellite nodes, those are smaller trees, but they're important too, in that they help connect the whole forest together. And the third thing I wanted to point out is that these seedlings then are regenerating in the network of these old trees. So the old trees will shed their seeds, the seeds germinate, the little roots that grow down into the soil become colonized within about a month by this enormous network, and they basically get fed by the network. So they get that enormous uptake capacity for all the nutrients and water in the soil, but they also are directly receiving carbon or carbohydrate or photosynthate, as well as nitrogen and phosphorus and water, and even defense signals and information from these big old trees. And this helps these seedlings to get started. It really gives them a head start so that eventually they become trees themselves, and eventually in time, mother trees, because forests are dynamic and ever-changing places. So here's a mother tree. These are just the biggest, oldest trees in the forest, and every forest has them. Even if it's a young forest, it will also have mother trees. They're just the biggest ones. And if it's an even-aged forest, again, it's just the biggest ones. And why is that? It's because they have these huge root systems, right? These root systems have lots of fine roots with lots of different fungal connections and lots of different fungal species. And the older the forest, the more diverse that fungal community is, which they all do different things. They have different niches and so on. And also because they have huge crowns, like huge leaf area, and that leaf area fixes tons of photosynthate, and that photosynthate ends up feeding this network, and then some of it ends up in the regenerating trees all around. So it really does, these old trees really are the connectors of the forest. They're the matriarchs. And back to the Aboriginal cultures, the old ones, the elders, were always honored and respected and revered. And it wasn't so much that they were old, it was about their role in their cultures and their society, that they earned this place as an elder, a person of wisdom who carried wisdom of culture and spread it and taught the young ones. So this is the same in forests. These elder trees have this as well. They have the knowledge of the past, it's encoded in their genes. They have the understanding of diversity and the importance of diversity. They host it on their root systems, and they care for the new generations coming up in a big social network. The other thing that these old trees can do is that they can recognize their own kin. This is brand new research that we've done, new in trees, that we've discovered that trees, they actually recognize which are their own seedlings, and that they transmit information and carbon to those seedlings to give them a head start, to help them carry on the genes of these old trees. This is called kin recognition, and it is changing how we view, I think it should change how we view and regenerate our forests. Let me get back to the First Nations a little bit. This is in the Heiltsuk territory. In the First Nation, which is a First Nation that's on the mid coast of Canada. And this is a village, it's called Hayot. and it's a 6,000-year-old village. You can't see it here. It's very much hidden. It's being re-established by the local people. But in this river here, there is actually one of those ancient tidal stone traps around here that you can't see it, but there are also clam beds, and there were, huge gardens to support the people that lived here. And these, so they would have had their tidal stone traps, and the fish would have spawned up this river. But the people weren't the only ones eating the fish. There's also the bears and the wolves, the ravens, the eagles also depended on the fish for their livelihood. So during spawning season, a bear like this, a grizzly like this, can take actually 175 fish up into the forest from the spawning bed and eat it they eat them under the crowns of these big old mother trees. And these fish, they don't eat the whole fish. They actually avoid the fillets, which is what we love, because they know that they have liver flukes in them and that they can infect the bears. And so they only eat the highly nutritious brains and guts and leave the flesh to decay in the soil. And that flesh, carries with it nitrogen. That nitrogen carries a heavy isotope because of N15, which accumulates in these fish because they live most of their lives in the ocean. But that heavy isotope actually allows us to trace where the remnants of these salmon go in the ecosystem. And it turns out that the mycorrhizal networks that we're studying this right now. I have a PhD student just finishing his PhD on this. These networks pick up these salmon and they take them and they absorb them into the tree, and the nitrogen of these fish, we can trace how many fish were in these rivers over the lifespan of that tree by looking at all the tree rings and how much N15 is in them. So in a 1,000-year-old tree, you could actually reconstruct a 1,000-year history of the salmon populations. You could reconstruct when the colonists came in and dismantled those stone fish traps and outlawed the fishing by the First Nations for profit, and they took over the fishery. And and we can also trace what happened to the salmon populations as a result of that colonialism. So as I mentioned, these fish, they decay, and the bones, you can find the bones in the forest right beneath these big old trees. And that's what we've done. And that's allowed us to actually reconstruct, the benefit of the salmon to the forest. It results in sort of the fertilization of these great iconic old growth cedar forests, which we all, in our imaginations love and know that they're so important to be there. And the fish depend on them as well. There's a positive feedback to the salmon where the forest, these huge forests, then shade the streams. They provide detritus to the streams which feed the salmon, and it creates this beautiful feedback loop, which invigorates and keeps the whole population, the whole ecosystem alive and thrifty and healthy. And of course, I just wanted to mention, this is actually what we call a culturally modified tree. The people, the Haida people, the Tsimshian and so on, they just harvested the bark of these beautiful old cedar trees with great care to make their clothing and baskets and mats. And they still do to this very day. So these old forests, so you probably have heard in the news that there's a great deal of protests going on in British Columbia right now because the last remnant old growth forests are under threat. We only have 3% of these iconic old growth cedar forests left. And there's corporations that are moving in to log these forests. And the people are up in protest because once these forests are gone, once they're cut, we will never get them back. The biodiversity, the genetics diversity in the past climates that are encoded in the seeds, we need those seeds in order to help our forests adapt and survive through climate change. So we need these forests for their ability to have that biodiversity and the immense amount of carbon that they store to keep our climate in balance. And it's heartbreaking to see, I think, that our whole country, our whole province, the First Nations are in grief over this. This is Haida Gwaii, a beautiful archipelago being clear cut. And, this has also led to, an unraveling of our ecosystem. We've pushed them to this tipping point where now, we're seeing fires, even, you've heard about them in Portland, in Oregon. That's also happening up in British Columbia. We've had 2.5 million hectares of mega fires in the last few years, and it's absolutely devastating to our forests. And people are standing up. The Haida are standing up. They've had enough, and so have the rest of us. And we're all kind of out there together protesting against the demise of our last old growth forests, to recover some of the knowledge systems that knew these forests, and to try to combine them with our Western scientific knowledge so that we can get back on a spiral of learning, so that we can recover our forests, so that we can nurture them back to health, so that we have a livable planet. And so this is, how do we start with this? Well, we get back to nature, right? We get back to our trees and love our trees and be with them. It only takes a person about 5 minutes to sit with a tree, like this First Nations man in Oregon, sitting with his tree to reconnect with nature and understand that we are all one, Netzamuts. We are all in this together. So with that, thank you so much. This is the Mother Tree Crew, who we're studying our forests with. Thank you so much.
Well, thank you so much, Dr. Samar. That was absolutely inspiring and very thought-provoking. I had the great fortune of getting an early copy of your book, so I'm not sure how many folks in the audience have had the chance to read it yet, but I did with great interest. And you touched on some of the things from your book in your presentation. But you also didn't touch on many of the things that I found maybe most interesting and compelling about the book. And so one of those was that your deep personal connection to nature from the time of your childhood, really to the present day, is a theme that resonates. It's a theme that resonated in your talk this afternoon. So my first kind of question for discussion is, how important do you think that connection to nature is, and how important do you think, or how much of a role did it play in your ability to maybe see and understand things about the forests, that the way the forests work, that your colleagues in the timber industry did not?
Yeah, that's a really excellent question. And I do, in my book, I do talk about this a lot and trace it through, because this is such an important part of this story, as you've hit upon. So I grew up in these inland rainforests. My great grandfather was a horse logger, as was my grandfather, all my uncles, and my dad. And so I just grew up around that. I grew up in these forests. I knew the forest as an entwined, integrated, connected place, a place of majesty, a cathedral. And when my dad and grandfather logged, they selectively logged. They would take a whole day to fall a tree, and they would pick that tree they would fall that day. Maybe it would take a couple of days to fall that tree. It was done really carefully and with a great deal of respect for the forest. And my grandfather always used to say, we only need this much. And they lived simply, poorly. They were horse loggers, but I know now, that as I moved into forestry and became a forester, that was kind of the beginning, right? Like, even though they were careful, that sort of, horse logging, they were on homesteads that were taken from the Splatsin Nation that they lived along the Shuswap River, the Suquamish people. And now I know that we were settlers that displaced those people. And even though we were careful horse loggers, we were not using Aboriginal knowledge to do that. They were just sort of making their way. But still, this shaped me, right? That it shaped how I saw the forest. And I was horrified when I became a young forester and I stepped into the modern forestry practices, which was to clear cut everything, take everything, all the mother trees, not just the mother trees, but the saplings and the little ones as well. And because it was efficient and it was, more lucrative. And not only that, we also were in this period where we were looking at agriculture to increase productivity of forests. It was really an agricultural model. And so that meant getting rid of all the plants that we didn't want to create these sort of perfect gardens that didn't have native plants, no huckleberries, no thimbleberries, no devil's club, no fireweed. And so they would spray them with herbicides. And I saw as a young researcher that this was just looked so unlike what I grew up with. Like, what are we doing to these forests? And so that's what got me on the track. And I don't think of looking at connection, because I saw us as disconnecting the forest. And I don't think if I hadn't grown up in those forests and saw what they truly were, like I understood them in my DNA as these majestic places, I don't think I would have been able to ask those questions, or at least do it so passionately. And maybe, other people didn't ask them because they didn't see the forest in the way that I saw it. So I think that one of the messages here is that science is such a human thing, right? It comes from our hearts, and that's important. It's not just this clinical, mysterious, weird thing that we shouldn't trust. It actually is about us, right? And I think that what helps me too in knowing that I'm on the right track is that when I talk to people about this, they say, I know this in my heart. This is in our genes. This is in our DNA. We are connected to these trees and in this nature, and we depend on it. We're all one in it together. So yeah, that was a long answer to your question.
No, I could listen to you, sort of all day. And the other things that sort of segue into, what was one of my questions about based on the book, but you went into very deeply in your lecture, is sort of Aboriginal knowledge, the First Nations knowledge. And, you just sort of admitted that even your sort of low impact horse logging family was doing so in lands that had been stored and intended for generations, for millennia. By the First Nations people who lived there before the European settlers came, and this has come up in some of the questions of the Q&A. So in eastern and maybe midwestern forests, I've learned that the Native Americans managed the forests to some extent, not for timber crops, but for food crops or to clear understory to make hunting easier or similar ways, kind of. They weren't untouched, these forests. They were lived in and they were used. Are there any traditions in the Pacific Northwest of forest management, manipulating either species composition or species or density of plantings? Are there any sort of traditional methods of managing the forest that could inform modern forestry practices?
I'll mention a couple. So one thing I didn't mention was that, how the salmon fertilize the forest along the West Coast naturally, right? They get carried into the bush by the bears and so on. But the First Nations, when they harvested salmon, they would keep the guts of the salmon, and they would bury it at the base of the trees. And so in that way, where they were promoting the growth of the trees, and especially, I think, although I'm not certain of this, but trees around their villages, which would also have been important for bark stripping, for making canoes and totems and longhouses. They wouldn't be able to, transport these huge logs long distances. So they would have cultivated the ones around the villages. And they did this, that was one example of burying the fish guts at the base of trees or at the base of salmon berries, which made the salmon berries, plump and beautiful and luscious. And the other thing they did is they would return the bones to the rivers, because the minerals and the calcium are an essential part of the diet of the salmon, or, to keep the rivers healthy and strong for the salmon. So those are two cultivation practices. They also, from what I understood, would also, sort of pick the trees well in advance, which would be the totem tree, which would be the tree that they would make into a canoe, and so that they could, sort of manage around those trees. I don't know how they did that management, but I know that they did select, and they still do that. They select them well in advance. And on Haida Gwaii, here's just a kind of a sad story, is that Haida Gwaii, which is like a beautiful island, part of it is in a park. The other part is where the nations live, and it's being clear-cut logged. And it's the plan by the government is to convert it to basically second growth forest. And there's not very many of these old growth cedars left. And the last time they had to select a totem, it took 2 years to find an appropriate tree. And so that is kind of where we're at, right? As far as other management techniques, yes, they use fire a lot. And you mentioned some of the things like to clear the underbrush to promote the growth of certain berries, to clear trade routes. They had incredibly sophisticated trade routes. The Ulukin is one that my research associate, Dr. Teresa Ryan, studied in her doctoral. She's Tsimshian Nation, and the Ulukin is a grease of fish that they used for making grease, and they had incredible trade routes all the way through to Alberta, and where they would trade this incredible grease. And so they could clear those routes with fire. So they had techniques. They've been somewhat documented, and there's quite a few of them. A lot of them using fire as well.
Fascinating. It sort of begs the question, and you're both maybe exactly the right person and maybe exactly the wrong person to answer this question. But again, in the book, you describe your very first job of, spraying Roundup over everything in order to, create, to give, and I love the expression, it's so Orwellian, in support of the government's free to grow policy, which meant what? What did it mean? What did free to grow mean? It sounds so good, but maybe it's not so good.
Yeah, it was, so we had been through this period of exploitation and with very little regulation and reforestation going on in the 1970s and 80s. And this is when I came on the scene. And so there was a lot of land that looked like it was covered with brush, and foresters don't like a forest covered with brush. They want trees. And so they decided, we need to enact stricter regulations in order to make sure that these lands are reforested. And that was a really good idea, right? But they fixated on this brush, these native plants, and said, this is the problem. They're competing with our trees and we need to get rid of them. And this practice was adopted from agricultural practices in the US. And the US was ahead of us really in the spraying of herbicides and multiple blankets of them. And so we learned that, and I'm not blaming Americans for this, but we adopted those practices. And so the idea was to get rid of the native plants, to make sure these trees were free to grow without competition, and they would become these huge, beautiful pumpkins that we could harvest in another 50 or 80 years.
And they did. And your research proved that if the goal is to grow carbon, if the goal is to grow the highest quality, kind of healthiest trees, and make them just resistant to malaria and other pests and pathogens, they were shooting themselves in the foot, right? I mean, that's what you sort of proven.
Yes, well, I saw, disease was spreading through these plantations. Now I know, after going back and looking at more of them, it's not just one pathogen, it's like 50 different insect and infestations and pathogens. There's so many damaging agents. And, in looking at the plantations, we found out that about a third of them will not actually reach a forest because they've got so many things wrong with them. And I think, an important message here is that, these old forests, they're full of biodiversity, they're healthy, and they are huge carbon storehouses. Plantations don't have those things, right? They're simplified. The carbon, you lose about right away, as soon as you harvest, about 50% of the carbon is, and that's the above ground part. The below ground part is still there, but it gets moved into different parts: toilet paper, paper products, some long-term storage, but about 65% of it, we assume, just evaporates into the atmosphere as soon as it's logged. And so, these plantations are not only just not doing well, but they're, compared to the old growth forest, there's no way that they have they're impoverished in so many ways compared to the old forest. And so, my plea to the government and the corporation, and to help people understand, is that we need to stand up to protect these old forests because our lives depend on it. Right. The plantations are not going to do it for us. I mean, they'll provide fiber for the future, but we need to, we can work with them, but we need to save these other forests for their values. Yeah.
Right. It's interesting. One of the Q&As from the audience, which is along those lines, is that maybe now that we recognize, in large part because of your work, that forest soils are huge carbon sinks. Maybe the economic value is not in the Douglas fir 2x4s and the cedar 2x4s, but maybe ultimately the economic value in these forests is in storing carbon because they're so good at it.
Absolutely. I don't think it's going to be very long before our economy shifts over that way. And probably most people have heard about carbon offsets, right? Where, and I think that this is a good, it's actually a way of putting a price on carbon. So we have to, if we're going to stay in our same economic system, which is not about to change anytime soon, as far as I can see, we've got to work within it. And that means putting a price on carbon and then purchasing that carbon so that it's in the forest. So like you said, some of these coastal forests where I live, the amount of carbon in them is incredible, right? The ones that the Fairy Creek that they're trying to log, it's got huge, it's just stock full of carbon. If we could buy that carbon and say, we're going to save it. If like Microsoft or some big corporation to offset their carbon emissions, and this is not a perfect scenario, but I think it's one way forward is to buy those forests and then for their carbon, and then they can, offset their own emissions. That this is one possible solution.
Right. The future economy, I think about this a lot. Canada is sort of positioned well for the future economy, particularly if, cap and trade becomes a global kind of market. Canada has two things in abundance, well, many things in abundance, but including water, fresh water,
Yes.
and the capacity to store an extraordinary amount of carbon across
Yes.
a broad range of ecosystems. So,
Yes.
maybe after all, your research started again with this very kind of personal and heartfelt observation of that something is not right with this, but then that you backed up with rigorous scientific research over time, and maybe it will finally find its kind of purchase in terms of policy, because the world is going to need it all that much more because of environmental change, climate change notwithstanding. That's so sometimes the benefit of good science is not immediate. Sometimes it's over generations of time. I would be remiss. The number one question, and there's some related questions that is interesting to me too. You described these networks, the mycorrhizal networks within native ecosystems. Is there something similar in a garden environment or a park environment? Can people kind of tap into that for the health and beauty of their homes and gardens?
Absolutely. Almost all of the plants in the world have these mycorrhizal associations. They depend on them for reproduction, really, to grow and survive and reproduce. There's only about 5 plant families that don't form mycorrhizas. That includes like the cabbage family. But for the most part, the carrots, the onions, the leeks, the tomatoes, most things that you grow in your garden form what's called arbuscular mycorrhizas. And these are a special group. Cedars also form these, maples form them, yew trees form them. They're different than in the Pinaceae family, which are the firs and spruces and pines. They form what's called ectomycorrhizas. But in your garden, it's mostly these arbuscular mycorrhizas, of which there's, it's a lower diversity group of fungi. There's only a few hundred species worldwide, and that means that they're quite generalists, and these networks can therefore form quite easily between your plants in the garden. And I'm going to harken back to, in my book, I described the First Nations, and again, Robin Wall Kimmerer talks about this as well, is growing plants as companions so that they have these, they're compatible in multiple ways. And one of the ways in which I study is how they're connected below ground by these arbuscular networks. But in the Three Sisters model of growing a garden, that's corn, squash, and beans. The beans fix nitrogen that add fertilizer to the soil. The corn grows tall and forms fixes lots of photosynthesis, and the beans can climb up the corn, and then the squash benefits from the from the photosynthate shared by the corn and the nitrogen by the beans, and also provides a mulch over the soil that keeps the moisture in the soil so that it's nice and wet as well for the other plants. And so they're all companions, they're all linked together by these arbuscular networks, and they help each other, they're companion plants. So growing your garden like that is a really, really great way to have and to connect with nature in that way as well, to know that that there are these highly evolved relationships that are very productive.
Yeah, it's sort of great advice. I know that maybe about 15 years ago, a lot of fertilizers for trees incorporated, I think must have been generalist mycorrhizae, maybe a handful of species. And to tell you the truth, I haven't kind of learned much about how successful they've been to kind of inoculating the soil with these mycorrhizae. But my sense is that a little bit, if you build it, if they will come. A lot of these fungal species are sort of prevalent and present already, even in disturbed urban and suburban soils. Is that true?
Yes, that is true. let's go from an old growth forest to a disturbed urban setting. An old growth forest would have thousands of species in it, of fungal species, and they all have their different niches. Like some might be really good at getting phosphorus from those tight soil crumbs. Some might be good at getting, at the water that's deeper down. Some might be good at getting nitrogen closer to the surface. They all have their niches, and they're able to, basically supply the tree with a greater abundance of resource that it can access from this big soil pool. When you cut down that forest, those thousands of species, a lot of them depend on old growth trees because they have lots of carbon moving into the root systems. They'll disappear, or they won't be there. There'll be a handful, maybe a half dozen species left, and I call these the weedy species. They're the ones that don't require much carbon because all you've got left now are a few plants, maybe some seedlings, and they don't have a lot to supply these, the fungal network. But as the trees grow up, they will. The diversity increases, and by the time they're 100 years old, you're almost back to where it was as an old forest. In a degraded environment, initially, if you remove the topsoil, most of those mycorrhizal fungi will go away. You'll have almost nothing left if the forest floor is gone, if the topsoil is gone. But the spores will come in and try to repopulate it, but it will depend on, what you get will depend on the host plants that are there, like the trees and the plants. I would imagine in the New York Botanical Garden, where you've got a great diversity of plants and trees, you would have a really healthy fungal population. Whereas, maybe in a vacant lot, you'd have maybe one or two species left. If you want to recover that vacant lot, what you need to do is bring inoculum in. And you talked about commercial inoculums, and that can help. But those commercial inoculums in a healthy forest, if you bring it in, they get quickly replaced by the native species. If you're in a vacant lot, they will be essential in helping those first plants get started. And once those first plants get started, they're kind of form a nucleus that you can grow out and enrich that ecosystem over time and recover it. So, that's the great beauty of ecosystems, is that they're built to recover. And we can help them do that with, by providing inoculum and forest floor and organic material and compost and so on.
Well, you've done all the hard work for us. You've gone out and made these observations over 30 years, and you've kind of seen it kind of work in real time. So thank you for that, because we can just take your knowledge and apply it and make our gardens more beautiful and our gardens healthier. Another question that's come up a lot, and whenever we have conversations about really pressing environmental issues, this is the question that comes up, understandably. What can we do? You're in the Pacific Northwest, and there's heartbreaking photographs of those clear cuts, contrasted with those extraordinary lush photographs of the cedar forest with the ferns that are 8 feet tall, and it's just kind of otherworldly. So what can a person in New York, and of course it's with the wonder of Zoom, you have people watching this from literally around the world. So what can we do around the world to kind of help be a part of the change for the better?
Yeah, well, I mean, there's so many things we can do, big and small, right? So the first thing, the easiest thing is just to reconnect with nature. Like if you're feeling disconnected, and we do have grief over disconnection from nature. Some people call that the nature deficit disorder. It'll help you and it'll help the forest if we can all kind of reconnect in the as best way we can. Even if you live in an apartment, that could just mean going and sitting with a tree on your boulevard or in the park, or sitting with your plants on your deck, just to reconnect with them, be with them, be quiet with them, listen. That's so important. That's the first step. And then, once you've regained your love for the forest and care about it, then you can step out and do things. So I mean, voting is absolutely imperative, because we have good governments for the environment, and we have governments that don't care about it and actually are destructive. And so voting is absolutely essential, is to vote for progressive governments. And then beyond that, so we did that. We voted for a progressive government in British Columbia, and then they continue to cut the old growth forest, in fact, faster than the previous government before. And so you got to hold their feet to the fire, right? Like if they're not fulfilling their promises, hold them to account. And if they still don't respond, then go protest, right? And if you can't go protest yourself, what I'm doing is I'm talking to media. I have a small role. We all can play a role in supporting that. And it's only through those pressures, push, and we have to be persistent and not stop, will we affect change? And, you see it in, I was listening to Bill McKibben and talking to Rachel Maddow the other day and talking about how Shell Oil is, the Dutch are making them pay 45% of the profits to fund climate change mitigation. And I thought this is a step in the right direction. We need more and more and more of that. And the way systems are built, because I study systems, I study natural systems, is that, that looks like there's imperceptible change, but those changes, those key mother tree policies, those key mother tree people that affect change to be supported. And then suddenly you'll start to see the shift. The shift will come, and then we start to solve the problem. This thing about, about Shell Oil, then there'll be another company and another company, and then signing on the Paris Agreement and, reducing, fossil fuels consumption in cars. All of those matter. And we all, I think, can play a role in supporting those kinds of policies. There's so much that we can all do, really. It doesn't mean you have to change your whole life, but just supporting the people that are out there fighting the fight.
Well, that's fantastic advice. I often wonder, because ultimately many of these problems come down to overconsumption and consumption in general, making purchasing decisions.
Yeah.
And, timber, there's lots of organizations that kind of market sustainably harvested timber or plantation grown timber. Any sort of quick advice on what to look for when purchasing timber? I mean, where should one get it?
That's a really good point. So, there's been this big push to certify lumber to be, it's certified to be sustainable forestry. And there's there's different standards that are out there and certification outfits, but now everything is certified. And yet here we are clear cutting. I grew up in a province of old growth forest. It's now a province of clear cut, and every single one of those companies is certified. Yeah. So how does the consumer choose, right? So I think, it's hard. I think we need to, again, we got to push those certifiers and say, you've got to do a better job. But there are certain things, of course, you can do in the marketplace. Like when you're going shopping for, furniture, it's easy to say, oh, I'm going to get that teak desk because it's so beautiful and it's kind of cheap. Well, that came from the Amazon, right? It's better to buy something that came from a second growth forest that maybe has been finished in a way that looks just as beautiful. You can make those kind of smart choices, or, and there's going to be market pushes, I think, to try to get people not to buy, products that are from old growth forests, whether it's in the Amazon or the old growth of West Coast of North America, or even the boreal forest of Canada or Russia. We need to be aware of where those products come from and just don't buy them, boycott them even, right? So that we can affect behavioral change in the consumers and in society.
Okay, well, that's excellent advice. I know that we're just about to come to an end. So before we move on, just thank you so much for taking the time to speak with us today, for your beautiful and inspiring book, and for all the work you've done. That's a 30+ year career, literally on your hands and knees in the woods of the Northwest, figuring out the way things work and sharing that. So your work is a great gift to all of us, and thank you for that. And do you have any last words for the audience before we sign off?
Well, do I have some last words? Just be with nature and love it. And if you've lost it, go love it again, and then you'll find your way forward. And just the fact that you're here is a great thing, and I really appreciate that you've been here to listen and be part of this.
Well, thank you, Dr. Simard. It's such an honor to speak with you this afternoon.
Thank you so much.
Thank you, Dr. Simard, for your information and for your very impassioned talk. To you, Todd and Suzanne, for the conversation, and to our audience for your thoughtful questions. So many takeaways from this past hour, but the most simple and profound ones: reconnect with nature as best you can, regain your love of trees, vote, hold their feet to the fire, persist. We are all one, as you said.
Yes.
Thank you, Dr. Simard. I remind everyone that in the chat, you can find a link to purchase Dr. Simard's book. Also, a reminder that next Friday, the 18th, we have a conversation with culinary historian Michael Twitty and chef J.J. Johnson. They will discuss the African-American hand in rice as foundational to American food, and they will also delve into the food traditions of Juneteenth, which is the following day. The talk is free, moderated by Dr. Jessica B. Harris. You can find the link in our chat. Please do join us. To our audience across the country and around the globe, until the next talk, thank you and goodbye.